Good morning and welcome everyone to the November California Nevada Drought Early Warning System Drought and Climate Outlook Webinar. Thank you to those that have joined us previously and then those who may be joining us for the first time. My name is Amanda Sheffield and I'm the Regional Drought Information Coordinator for NIDIS in California, Nevada. We co-host this webinar with the California Nevada Applications Program and NOAA RESA team. This bi-monthly webinar series is designed to provide the region with timely information on current drought status and associated impacts, as well as a preview of developing climatic events. Before we get started, I just want to note for you all that this webinar is being recorded, and the recording and a brief summary will be available through drought.gov and on our NIDIS YouTube channel later this week. I'll enter some information in the chat so you guys can find that stuff later, but you'll also get a post-webinar email with all that stuff. We have a great set of speakers this week, going to cover current conditions and outlooks, as well as do what we usually do around this time of year is cover tools and resources for your winter toolbox. So we'll come on later. Those are some great things for you to follow and track as we keep going through this winter. The speakers I'll more fully introduce later and then pop in some information for them into the chat box as well. But I will actually be providing the Drought and Climate Update today, followed by John Gottschalk from the National Weather Service Climate Prediction Center, who's going to provide the Outlook. And then Julie Kalansky, who's from CNAP and CW3 at Scripps, and myself will be providing some tools and resources, as I said, for your winter toolbox to get things started for the year. Before we do that, just a little background on NIDIS for those who may not know about us yet. Our mission is to improve the nation's capacity to proactively manage drought-related risk by providing those affected with the best available information and resources to assess their potential for drought and also mitigate, prepare for, and respond to the effects of drought. We do this in many different activities across improving drought prediction and forecasting, supporting drought planning and preparedness, strengthening collaboration, supporting drought impact assessment, and leading the U.S. Drought Portal, drought.gov. As I mentioned, I am the coordinator for California, Nevada. You can see it's one of several drought early warning systems that we have to meet this mission. And what is the regional drought early warning system? Basically, we work with new and existing partner networks in these regions to make that information readily available, understandable, and usable, and to better monitor, forecast, plan for, and cope with drought. With that, I'll go ahead and get back to why we're here today. As I said, I'm going to be giving the drought and climate update, so I'll launch over into that. And I forgot to mention that if you have any questions during the webinar, question and answer will be all at the end. So go ahead and enter those in the questions box and we'll get to those. Maybe a brief one while we change speakers, but mostly at the end of the webinar. All right, as I said, I will be giving the update today. As you probably remember, about a month ago, so one of the big things I'm going to be talking about here was just under a month ago, the big atmospheric river event that occurred and what that means for drought, but also talk about a little bit about why did that storm not get us out to drought? What's still going on? What needs to do to go forward? And how a lot of this will depend on where you are and how drought impacts you. So let's get started looking at the current drought status in California, Nevada. Here on the left is the California, Nevada U.S. Drought Monitor, and here is the change since the start of the WADA year, so since just about October 1, 2021. As you can see, both states still remain 100% in drought according to the U.S. Drought Monitor. We've got the biggest core patches of exceptional drought, or D4, here in Central California and over into Nevada. While we did have some improvements here over the last just under 2 months, it's very regional in the areas. So some of the areas that had the atmospheric rivers and things like that. But overall, the area still remains really entrenched in drought. I'll mention a little bit, Southern California obviously has been a little bit slower to come into drought. They didn't have quite as bad as the 2 whole years, and so they're currently in some of the not quite as intense drought categories. But if we see anything like John may talk about with La Niña coming, we may see more intensification in some of those areas depending on what happens. Just to talk a little bit about recent impacts, you probably have seen a lot of these already in the news in the different areas, but I want just to highlight, these are actually some just only from the last month. I grabbed a few, how impacts really do continue to accumulate in the region, and they really can vary by time of year and the length of drought. So being in drought this long means we're starting to see a lot more agricultural impacts like almonds and things like that, energy impacts for hydropower, salmon impacts. There also is the different connections with wildfire. different drought declarations have happened or continue to happen, and now the full state of California is under a drought declaration. So I just want to mention here that, and these are only just a snapshot of from the last month, but they do continue to develop, and we'll continue tracking these and watching them as we go through the year. But you also have the opportunity to provide your own drought impacts. Before I just really dig into the update, I want to mention to remind you about CMOR, the Condition Monitoring Observation Reports. This is a place where you go to the website, you're able to enter in your drought impact reports, which helps the U.S. Drought Monitor process and state and local level decision making. And so I encourage you to, as you're monitoring drought for whatever reason you're monitoring, to enter impacts in there, including photos you can, or think about how to submit them. There's other ways, pathways to submit them to your state or your state climatologist or the National Weather Service. All right, so what did the last 60 days since our last webinar look like in California, Nevada? Here on the left is our percent of normal precipitation, and on the right here, our departure from normal temperatures. So as you can see, the large storm that happened in October that I'll talk about a little bit more really did impact a lot of the northern tier of the region, but we're still relatively dry here in the southern areas. And then here for temperature, I think it's really mixed with some of these cooler areas, but then also warmer than normal temperatures in some of these areas too. So as I mentioned, there was a very large atmospheric river around October 23rd to 26th. This was a part of a 3-part series of atmospheric rivers that impacted the whole west coast of the U.S., with the third one primarily coming into here in Northern California. This, according to CW3E and their AR scale, it was an exceptional AR, or AR5, and it did bring in several records or other notable things, including the cyclone that this atmospheric river is associated with broke the Washington Coast Pacific Cyclone low pressure record of 942 millibars. A lot of 24-hour rainfall records were broken. Lake Oroville rose about 170,000 feet. Here's a graphic of following through the water years, millions of acre feet stored in Lake Oroville. The blue line being the actual and the others being things like the median and other percentiles. And so you can see the little jump here in Oroville that happened, but did leave it still below, say, the 25th percentile in some of these areas. So while it got a jump, it didn't refill the reservoir or anything by any means. Over in Reno, this storm brought about, I think I have down 2.92 inches at the Reno airport, which actually was just shy of what the entire water year brought last year of 3.01 inches. And another notable was this storm caused Lake Tahoe to rise 6 inches in one day from this event, which brought the water level back to just above the national rim, which it had dipped down just before. And so as you can see, it brought a lot of precipitation and some snow to the region, but I just want to mention that it did increase runoff, stream flow, wetted soils, which really could help for next spring. But overall, the region is still in drought, as you saw. So we actually put up a drought status update on this event that you can find down here for more information if you want to dig into this event some more about what did this storm mean for drought, why isn't the drought over, and then could this be a start of a wet winter? And I'll actually dig into some of this in the rest of the presentation. So I was looking up from the water year to date, and the first figures like this. Well, this is November to date. So after that large storm, things, while there has been some precipitation in the region, especially here in Northwest California, a lot of the area still has been dry and warm since that large atmospheric river. So basically October never really guarantees that we're going to have a wet winter per se or things like that. And so we'll have to track closely to see what happens in the coming months. But thus far after that storm, it's been a lot of dry and warm temperatures. Here's just to dig into that a little bit further on the current conditions. Here on the left is just from the climate toolbox. This has a historical water watcher here looking at precipitation, reference of evapotranspiration, and vapor pressure deficit. You can really see the impacts since the start of the water year of that large atmospheric river and some of the improvements regionally to the total moisture, which includes soil moisture here. But in the short term, we've had these, we have these benefits from these storms. We had reduced fire weather, wetting of the soils, which could really help come next spring. Here on the right, I have snow water equivalent map from NRCS, was showing that some areas in the Sierras was able to make improvements with the storm, but really it's really early in the season to be able to tell much about how the entire season will develop, including snowpack. and you still see a lot of for these different watersheds, browns and oranges and things, versus blues and greens, which are the areas that are doing the best. Basically, there's so much long-term impacts of droughts that we need to recover under both hydrologic and ecological drought indicators, like groundwater aquifers, plants, ecosystems, wildlife, that it can really take months to years of normal to above normal precipitation to recover. And so basically there's no one size fits all to drought ending a recovery process. And so we'll continue to watch this and see how the winter develops. A little bit how those reservoirs are doing. As I mentioned, we did have those storms, but it has been relatively dry and warm since then. Most of the reservoirs here in California remain below their historical average marks. This is from California DWR here. And on the right here are similar graphics that I showed for Lake Oroville, but for Folsom Lake and Lake Tahoe, through the different water years, this thick blue line, what the water levels were. And while they both had a jump as well from that storm and subsequent precipitation, they're not quite even up to their median levels, which is this dashed line right here. Over in Nevada, this was on the left here was the change in the Nevada reservoirs from late September to late October. So you can see most of this time of year, these reservoirs are actually in the negative. They're usually dipping down this time of year. So the October rain did help increase these reservoirs some, especially when it's atypical. Normally they're still dropping at this time of year. But here's their actual current capacity compared to average capacity. You can see some of the reservoirs still have quite a ways to go with those. And these figures come from the Nevada Drought Update from the State Climate Office. You can find this from their website, livingwithdrought.com, and other information about drought in Nevada. I'll briefly mention here too, obviously one of the reservoirs in Nevada is Lake Mead, which continues to be low and is in its, as you probably heard in the news and other areas, is in its level 1 shortage area. Here on the left is different graphics from Metropolitan Water District's Water Supply Condition Report. I won't mention a ton here, but if you are interested in hearing a lot more about, say, how the Southwest overall is doing, including Lake Mead and things like that, there is a webinar tomorrow, more general on the Southwest. It's another one of the nicest webinars co-hosted with partners, including the Southwest USDA Climate Hub. But if you want to dig in deeper into more about the overall Southwest, separate from California, in there, you can attend this webinar tomorrow as well. So what does this mean then for why isn't the drought over, how we may recover? Parts of California, Nevada, as we came into this water year, were missing 1/2 to a full year's worth of precipitation in some areas, some even higher. The state of California Department of Water Resources was reporting they needed 140% of average statewide precipitation to sort of, work on that moisture deficit that's in the system. So here's another way to look at that. These figures are provided by CW3E in cooperation with Mike Dettinger. Each of these graphics display what would it take based on climatology, based on history, to get back to a normal water year. And so it doesn't include any forecast information, just climatology, what's happened in the past. Here for this water year, what would it take to reach normal? So from 50% of normal to 100% of normal to 150% of normal. And the second graphic here is thinking about the 2 years. So last year's dry year and this year's water year, what would it take? And so looking at this 100% of normal panel, looking at these blues and green areas, we do have some higher odds of reaching 100% normal because we had such a great start to the water year in some of these areas. But you still need quite a bit more to actually, reach those areas and things like that. And then when you actually look at the 2 years as a whole, so water year 2021 and 2022, to reach 100% normal, you see there's a lot fewer of those blues and green areas, a lot more reds, whites, oranges, and things like that, because we had such a dry year. So even if we have a normal or a good year this year, there's still quite a bit of deficit to work through, thinking about how many years of drought we've been in this far. And so the next presentation from John from the Climate Prediction Center will talk a lot more about the forecast, but and a little bit about La Niña and which is currently occurring right now in La Niña. These are figures that help us look at here in the blue, La Niña and these different areas of California, Nevada. So the southern coast of California in southern Nevada, what do past La Niñas have shown? And most of those are more reliably here, bunched together here. A lot of the La Niñas have been dry in these more southern type of areas, which is what the forecasts I think John will talk about. We'll see if they reflect that too. But that's more for the southern areas. Here more into the northern areas. So for example, this area of Northern California here, the blue dots are more spread. So La Niña is a little bit more of a coin toss historically in Northern California. And these figures were provided by Dan McAvoy from the Western Regional Climate Center. He produced these to sort of answer this question, does a wet October mean a wet year? So these are for two different areas, one here for Tahoe City, California, which I think had its wettest October on record at this station, and San Francisco, which had the second wettest October at this station, looking about how, if it rained or snowed in October, how does that compare to November and March precipitation? And basically, October is not a guarantee for a wet or dry year. Here we've had some 76, 77, which were both dry years, but one had a wet October, one didn't. 2017 is out here, which had a wet October and a wet year. But then there's years that had a wet year, but had a dry October. And you see that's sort of the same for the station as well. So basically, there's not enough to say how much a wet October doesn't necessarily mean a wet year. We'll need to continue tracking throughout the year. With that, I'll summarize. Basically, California, Nevada drought has stayed fairly consistent since the start of the WADI year, which is October 1. There's been some regional improvements for those that have been getting precipitation. In October's Amazon River improved conditions in Northern California, Nevada, including soils, which could help next spring. But the drought has built over many months to years, and autumn storms do not necessarily mean that the rest of the winter will be wet. And drought impacts can continue. We'll continue tracking those as they're part of the drought situation. And continued precipitation will be critical to drought relief. And just as a reminder that we need to monitor not just precipitation, but also temperature as well. Temperature is increasingly playing an important role in how drought develops here, including snowpack, how snowpack develops, evaporative demand, things like that. And so just a gentle reminder as you're thinking about the winter and playing with the tools that we'll be showing with you, so keep considering temperature as well as precipitation. All right, with that, as I mentioned, put your questions in the questions box if you have any. I can try to answer if there's any quick ones here myself in the chat, or we'll do most of the questions and answer at the end. So right now, though, I'm going to pass it over to John, who's from the Climate Prediction Center, who will be providing the Drought and Climate Outlook. Go. It should be passing over to John here.
Yeah.
There we go. You look good to go.
Okay. Thank you very much, Amanda. And again, thank you for the opportunity to speak today at this webinar. As Amanda mentioned, I'll be going over the latest Enso outlook and climate outlook, where we're referring to temperature and precipitation outlooks from CPC, and of course the drought outlook running through February. If we go to the next slide here, first some just recent observations related to the La Niña ongoing. As you can see on the left-hand side, things are coming together very nicely in the ocean surface temperature or sea surface temperature pattern, departures from normal. As you look along the equator from the date line towards the South American coast, we're seeing more substantial, more uniform anomalies, especially across the East Central Pacific, as indicated by the blue shades there. But we also see the classical horseshoe pattern of above normal temperatures to the north and to the south of that, from say north and near New Guinea to north of there, east of Japan, and further north and east into the northern Pacific, and similar across the southern South Pacific east of Australia. That's a very typical pattern in the ocean surface temperatures for an established La Niña. And also, one of the most important things, obviously, the sea surface temperatures or the ocean signature for La Niña is not the only factor We need certainly coupling to the atmosphere, and we have seen that in the last couple of months, and why we issued the La Niña advisory. If you look on the plot here on the right, the red and orange shades indicate suppressed tropical rainfall. This is outgoing long-wave radiation anomalies, a proxy for tropical rainfall, and you can see drier conditions have been observed over the last 30 days or so in this average west and near the date line, continue to become more expansive, and generally enhanced rainfall or enhanced convection across much of the Indonesia region and parts of the Eastern Indian Ocean. So we're seeing coupling in the atmosphere from the change in the ocean surface temperatures. I don't show this here, but also the trade winds have, on average, have become enhanced across the central and western Pacific as well, and we're seeing upper level circulation changes in the wind field as well. With respect to that's the observation point of view. From the model point of view, what's shown on the left are projections for an area in the central Pacific, referred to as the Niño 3.4 region, which is just the box across the parts of the East Central Pacific Ocean that we monitor quite closely. And this is a forecast from a number of short-term climate prediction models that extend out a number of months for that particular variable. And what's shown here, first, if you take a look, the zero line is indicated by the solid line, and minus 0.5 degrees C is that dashed line just below that. The black line, solid black line, is the observations of that Niño 3.4 average value, and the corresponding lines from that point forward are various models that forecast this parameter out through the month of June in this particular case. You can see the different models there, and the ensemble mean, or the average of all of these 6 models, is the dotted bold line through here. And so there is variation, of course, as there always is. Some model guidance is playing more of a, let's say, a weaker end moderate event near this minus 1 degree value. Other models are forecasting more of a stronger event on the higher end of moderate event or near a strong event. The mean is right through the middle. That's kind of basically what we've been going with in the latest assessment, that's probably most likely right now would be favoring a moderate event, but perhaps on the high end of that range. These SST anomalies will peak probably December or January, so is indicated here, and then will begin to decrease as we move towards the spring months, and then towards Enso neutral conditions, at least at that time in the model guidance from the April through June period. The official forecast that takes in the latest observations and the model predictions shown there on the left, indicate obviously very strong odds for La Niña conditions to continue, greater than 90% and greater than 80% through the January, February, March season, decreasing to about 50%, which is the blue bars here, by the March, April, May period, where we then expect Enso neutral conditions to be favored, which they often are as we get into the late spring months into the early part of the summer. During the January, February, March period, you can see the odds for La Niña are over 2 times their climatological probability, which is in this case is the blue line, solid blue line on these maps. I think most people are familiar with what La Niña is. I'm not going to spend much time on this. As I've shown, this is La Niña is a cooling of the ocean surface temperatures, as indicated in this plot here on the upper left. And again, as I mentioned, typically you see warmer sea surface temperatures are to the north and south of that area. To the bottom, it shows what typical impacts often are. With respect to during a La Niña event during the winter, the East Asian jet stream or the Pacific jet stream is often retracted on average over the winter months closer to the Asian coast, or does not extend as much as often eastward. And so you can often have higher pressure across the Central Pacific, North Central Pacific, sometimes more in the way of blocking, depending on the situation. And so you tend to ultimately have, in layman's terms, basically a storm track generally shifted to the north for most intents and purposes, with producing wetter conditions in the Pacific Northwest, Northern Rockies, and even into Northern California at times, and then drier, as Amanda mentioned, across the southern parts of California and Nevada, and across the Southwest. And I won't go into the impacts shown here too much more, but one thing I do want to highlight is this condition that if you look at La Niña events in the historical record, you'll see a very highly variable winter seasonal precipitation amounts pattern for during La Nina. Sometimes they're actually below normal precipitation-wise in the Pacific Northwest, Northern California. Other times near normal, other times wet. These impacts that I've mentioned across the whole West Coast or Western U.S. are an average of all La Nina events in the historical record to try to come up with a composite or an average typical impact. And so that's very important to keep in mind. And Amanda alluded to that. It's going to be something that we have to watch, month to month, week to week as we go through the water year. So we're starting with the outlooks part of the talk from first part of the month of December. What's shown here are the temperature forecast on the left and precipitation on the right. The orange and red shades indicate favored above normal temperatures and the monthly mean temperatures for the whole month of December. We are favoring above normal temperatures for most of California and Nevada, the highest odds across the Southwest. For precipitation, again, with respect to La Nina development, potentially in the sense of impacts, weak signals for drier than normal conditions across Southern California and Southern Nevada. Again, this is for the month of December. And then for the northern part of the West Coast and Northern Rockies, favoring above normal precipitation, especially across the Northern Rockies, as indicated with a slightly higher probability. The legend indicates the probabilities of this particular map that is shown, meaning the colors or the category. What's shown in those previous maps are the favored category, but I do want to spend just a minute to talk about that's very important to realize that every point on that map is really designating probabilities of all three categories. We just don't necessarily depict it on that standalone map. So we have available to us on our webpage as well what we call, basically we can point to a given location on the map, as I've done here for the temperature forecast for December. And when you click on that, you can see what the probabilities are given the forecast for each of those categories, the below normal temperature category, the middle or near normal temperature category, as well as what we're favoring, which is the above normal category. And you can see that the probabilities are pretty substantially elevated, at least at this particular point, of near 60%, which is almost 2 times what the climatological probability would be for any one of these categories, given it's a 3-class system of 33%. But you also notice that the odds are significantly reduced for below normal temperatures, even though the above is not any near 80 or 90%. There's still considerably less likelihood, significantly less likelihood for the below normal temperature category, for example. And just on the right-hand side is just to illustrate a similar analogous situation in the sense with above normal precipitation for the Northern Rockies, for example, and you can see the distribution of above, near, and below normal precipitation is indicated here. So it's very important that we go through this. There's sometimes often confusion as to the various amount of shading on the maps. They're not indicative of magnitude of above normal. They're just indicative of the odds of being above normal or in that upper third of the distribution. So using these tools here forces folks to understand that there's distinct non-trivial odds for all three categories typically. So moving into the winter months itself, now for December, January, and February, temperature and precipitation on the left and right, similar to the last slide. And these are largely informed by La Nina, but other statistical guidance tools, which I'll talk about later, as well as dynamical model guidance, generally indicate that right now the forecast is for favoring below normal temperatures in the far Pacific Northwest. We will notice that there's a weakening or decrease in the probabilities for above normal temperatures in the Southwest, parts of Southern California and Nevada, as we tend to see as we're going through the winter season, generally more of a tendency for more elevated likelihood or increased likelihood for below normal temperatures shifting from the northern plains, northern Rockies, to the Pacific Northwest and slightly down the coast in California. As we typically see blocking, there's very often colder sea surface temperatures that develop along the coastal areas off the West Coast associated with that circulation pattern. And also important to note the probabilities for above normal temperatures decrease, although we're still favoring those, they do decrease as we move forward. Probably a big factor also, as you look to the right, you can clearly see, and this is not inconsistent with what Amanda showed and what composites show, and basically all of our forecast guidance products show, is that there's a tendency for below normal precipitation for, say, the bottom 2/3 of California, but it's important to note again, these odds are really quite modest. The tilt towards drier than normal conditions in this first range are basically 32 to 40%, where the climatological probability is only 33%. In the darker shading here, it's more on the order of 40, greater than 40%. So these are still relatively slight shifts towards drier than normal conditions, but that is what we are favoring. A little bit higher odds as we get further to the south, in the southwest and parts of western Texas. As we go into January, February, and March to show the evolution of what I was describing, favoring below normal temperatures, again at modest odds to shift across parts of Northern California to the Bay Area, with less and less likelihood of above normal temperatures shifting more into the southwest. The white areas that we refer to as equal chances, all that indicates is that there's a climatological probability for all three classes, and that climate signals or historical forecast skill and reliability were not such that we could feel like we could produce a reliable forecast in those regions. If you look to the right for precipitation, you'll see again a similar scenario, but with a little bit slightly increased probabilities. The northern edge of this area towards Northern California, but again a slight tilt, but also more of Southern California in that greater than 40% probability during the January, February, March period. So if you go back and forth, you can kind of see the evolution that I was trying to describe as what we kind of expect between the first season and then the next season. We intentionally do these forecasts with 2 months overlap to generate a more smooth climate evolution, which is what we typically would observe. Moving to the drought outlook for December, January, and February, obviously the temperature and precipitation outlooks play a large role in this. Given the good start to the water year, I believe, across Northern California and into the Pacific Northwest, and prospects, as I showed there, for the rest of over the next season or so, or two, we have a pretty large area of favored improvement, which is the gray shading, and removal, which is the green shading across much of the Pacific Northwest and Northern Rockies. Persistence across much of the Southwest, California, Nevada. However, with drying conditions favored on average as a result of La Niña conditions expected to persist through the winter into the early spring, we are favoring additional drought development areas across parts of the Southern Plains and as well as the Southwest. And this is for valid conditions at the end of February 2022. I briefly want to go through, in addition to La Niña background conditions that I showed earlier, we make use of other statistical and dynamical forecast tools and guidance to help us. In addition to that, we're able to produce an objective, historically skill-based first guess or consolidation of that information, and we're able to adjust that as we move forward. And we have increasingly over the years, short-term climate prediction models do play a larger role than they have, say, 10 years ago. And my point of this slide here is not to go through the meaning of these different statistical techniques or tools that we use, more that we do use these in addition to just the pure dynamical model guidance that we often show. This is an example of some of the products the forecasters has available to them. This is for December, January, and February for 2021 through 22 for temperature. And on the bottom row, we have a number of different statistical type methods that are shown here. On the right is actually also the longer term trend tool that we're able to make use of. And up in the upper left, we're able to consolidate, as I mentioned, or combine various forecast tools objectively using the independent information from the different versions, different types of tools to come up with the best guess forecast from the statistical tools point of view. What's shown in the middle is the North American Multi-Model Ensemble forecast, which is dynamical model predictions. And finally, on the upper right is a combination of all of the information, the statistical information on the left, the dynamical model information in the middle here, and then getting the forecast here on the right. So that's mainly this is for temperature. Focusing on some of the dynamical model predictions that we do have. This is an example for the forecast target period of January through March of 2022, but for precipitation. And this shows a number of different model forecasts that we have from various centers across the world, including NCEP here in the Weather Service in DC, as well as Canada and other research institutions. And we also have information from ECMWF and so on that's not specifically showed here. But you can see in the bottom two rows various forecasts from these models that generally show the same thing, but there are some slight differences, and so subtle differences. And so the mean of all those forecasts is in the upper right. This is the deterministic ensemble mean forecast. The probabilities of those forecasts are shown here just after bias correction to remove any systematic errors from those models. And then on the right, we calibrate it based on historic scale as well, which is in the upper right. So you can see there's a general decrease in coverage. And so that's why we try very hard to make sure that we focus on the signals where we feel like we have a reliable signal based on past forecasts and observations and how they are verified and observed with past events. And so to summarize, first the forecast, as I showed, the winter season mean temperatures are favored to be above normal for parts of California and the Southwest, especially early on in the winter. There's a tendency at the current time for those odds to likely decrease as the winter progresses from west to east by the time we get into the late winter and spring. Below normal temperatures, however, remain likely for the Pacific Northwest and Northern Rockies, and then later potentially across Northern California, or especially along the coastal areas as we get through the January, February, and March season. For precipitation, again, Pacific Northwest, Northern Rockies remain very favored to continue to have a good water year, at least all things that we're seeing at the current time. However, dry conditions are most likely across the southern half of California, at least the central and southern half of California, Nevada, and into the Southwest, with the highest odds further south and east as you go in that region. However, as I noted before, there's going to be a lot of variability likely from one event to the other, as we've seen in the historical record. There'll be quite a bit of variability with respect to the precipitation. And so that area, say Northern California, is unfortunately in a very weak climate signal region. For the drought forecast, conditions are expected to improve in various ways across the Pacific Northwest and Northern Rockies, but are likely to develop across some areas of the Southwest and Southern Plains, depending on based on the forecast of below normal precipitation. I already mentioned La Niña as one of the important drivers in the outlook. And finally, one of the most important points I do want to make is that CPC does release, obviously, shorter-term outlooks throughout the winter season. Some of these are quite short in the sense of the week 2 period for temperature and precipitation, and also for hazardous events. For example, atmospheric river events that may produce high amounts of precipitation over a short amount of time, over a 1 or 2 day period, in our weekly U.S. hazards outlook. Also, outlooks for temperature and precipitation for week 3 and 4, and of course monthly. And these really should be monitored as we go through the water year and the winter season. The temperature and precipitation expectations within the winter are likely to be variable, and there'll be periods of wet and dryness as we go through. And that's very typical of, as I mentioned, for La Niña year. La Niña winters is generally higher variability, especially along the West Coast. And so I would urge and suggest folks to monitor these sort of shorter-term outlooks as we go through the whole winter season to help with their decision-making and planning moving forward. So I thank you very much for your time. I appreciate it, and I'll throw it back to you, Amanda. Thank you.
Thanks, John. So this next part of the webinar is where we'll move on to our tools and resources, and I'm going to pass it over to Julie Klansky from CNAP to get us started about CNAP tools and CW3E tools, which she also works with. But John, we have a quick question here. Maybe we can ask you here while I transition over to Julie. I think they sort of just want to connect the dots a little bit with what you said. And so their question is, are atmospheric river events correlated with Enso cycles? Are they more prevalent during La Niña years? I don't know if you could say anything about that.
Yeah, I mean, that's a great question, but a difficult one. I would have to probably read through some of the literature to be most certain about my answer, but my general feeling is that that's not really related necessarily to the Enso cycle. But In many ways, some of those events are related to subseasonal variability, in the sense things like the Mad-Julian oscillation can have enhanced rainfall and winds, and the whole wave, basically the wave cycle of an MJO event can bring convection out into the dateline. That's less likely during La Nina, though, with the cooler SSTs. But having said that, as I mentioned earlier, with the general blocking pattern or region that we'll have across the Pacific, what happens very often is that we'll have a trough that will be on the east side of that ridge that will come down along the western part of Canada, western Canada and the western U.S. and just off the coast. And very often the southern stream and the jet stream and that northern branch will sometimes tend to meet in the Pacific Northwest, Northern California regions, and anywhere around the West Coast, actually, depending on the circulation. And if that happens very often, you can get very good plumes of tropical moisture from the Western Pacific or from near Hawaii in that region, for example, and that can occur. So it's really hard to say, I think. It's really hard to say.
All right, thanks, John. Julie, want to pass on to you?
Great, and I assume everybody's seen the website?
Yes.
Good on your end? Okay, great. So thank you for having me. And I'm gonna actually be going through the websites. I don't have a presentation. I do this because I think hopefully it makes it easier to find what I'm showing later on. As Amanda mentioned, I wear two hats. I work with both CNAP, which is focused on California and Nevada. It's a NOAA RISA team, and the Center for Western Weather and Water Extremes, CW3, both located at Scripps. And so I'll start with the CNAP page, and Amanda made this pretty easy for me because she showed a lot of the products that I will show. And I think the most relevant ones for this is under observations. And so there are quite a few here. So if you go to observations and the Precipitate Tracking in California, Nevada. And so this has been set up by Dave Pierce in a collaboration between CNAP and CW3E. And so what this is looking at, I'll go through the whole thing and then describe, is different precipitation and event changes from day to day. And so, for example, this is in San Diego. There's many other locations, which I'll show in just a second. And this is the current percent of water year precipitation that we have. The first line going across is a record low. This is the typical low, which is the third percentile, the median, and the typical high and the record high. And then this is 2004, actually, it would be today in 2000, or here's today's date for in 2004 would have been the record high, and the record low would have been in 1999. And so what you're seeing is this 1 day delta, 2 day delta, 3 day delta is showing the change if, for example, San Diego got precipitation, what that change was over the last day. So how the storm, the amount of precipitation and percent of water year total did that storm bring. And then again, here you're seeing the 50th percentile, the 90th percentile, 95th, 99th, and record, and the years when the record was reached. And so you can see this, you can see the 1 day change, the 2 day change, and the 3 day change. And then on the right here is, how this water year is going relative to all years, which is the light blue shading, the middle 2/3 year, and the median, which is the dashed line. And so it's a little small here, but for 2021, we're at 22, or for 21 and 22, we're at 7.1%, which, is relatively close to this median value. And so I'll just scan through the website so you can see where else we have this for. So the greater Los Angeles region, all of California, the Sierra 8 station index, which the storm hit, and you can see for this year, because that's the storm that Amanda talked about, that AR5 is doing particularly well for right now. And then also in Nevada, we have Clark County, which is still, very low as of right now, and the Reno Carson City region. And you can also click on these images to make them larger as well. I have to admit, my husband isn't in the climate weather world at all, and this is one of his favorite websites. He is usually the first person I hear from if it's not, for some reason, acting properly. And so it's a very nice way to kind of keep tabs on how your region is doing and kind of what that storm brought to your region. The other one under observation is this water storage tracking. Amanda showed some of this, and this has been produced by Mike Dettinger. And so what this, we've used this, or at least I think generally we've used this a lot in the webinars, the climate and drought status update webinars. And so what this shows is the average, this dark blue for the reservoirs, and this figure on the right is showing what reservoirs are tracking, and then the snowpack, and then how that compares to kind of the normal snowpack. And there's several of these. Again, I'll scroll down, and you can see what normal is. Each figure labels the normal. Because snowpack is relatively low this year, and this time of year, and it doesn't really often start recording. Mike hasn't started these over for the 2022-23, or sorry, the 2021-22 water year yet, but these usually start again, and we'll just show this next water year in late December. But you can see where, for example, where this storm in October, where there was that uptick. And so Mike does this for quite a few different locations all throughout California and Nevada. And so here he breaks up those 28 reservoirs and areas into Northern California, Central Sierra, and Southern Sierra. This is the historical trend in thinking about major reservoirs versus minor. Looking at Upper Sacramento, Yuba Feather, just the Yuba, Lake Tahoe, and as Amanda mentioned earlier, you can see this is where it dropped below the rim, and then where the storm in late October, the AR, brought it back up above the rim. And then he also does this for the Upper Colorado, where he looks at the reservoirs above Lake Powell and the snowpack. And then also he includes Lake Powell here as well, so you can see how Lake Powell's doing relative to those. And then going back up, the other thing on this page which you can link to is this tracking of the major reservoirs in California, Nevada. And so here you can see what reservoirs are on this page that are being shown. And this is what Amanda talked about in her presentation, where it starts in water year 2019, 2020. It goes so kind of throughout this current drought, and then added up this most current water year. And then you have your record low, your record high, and the second percentile is the orange, low and high, 5th percentile, 10th percentile, the 25th, and the median. And so you can see how well it's doing this year. Mike also provides the inflows and outflows from the reservoirs, and just for reference to see how the reservoir behaved and did during the last drought, to help for that comparison between the current drought. And I won't go through all these. Amanda showed a lot of them, but if you go back up here, you can see what reservoirs this is available for. Staying on the CNAP page, if you go also to observations, I'm going to actually open this in a new tab. So this is produced by Dennis Ledenmeyer at UCLA, and it is looking at modeled, and it uses two different hydrologic models, the VIC model and NOAA-MP. And so it looks at total moisture and soil moisture and measures it as part of a percentile. And so you can see here how the two different models compare. And one thing, because there's some uncertainty based on the models, if the models are showing the similar patterns, that gives more certainty. And I'll talk about this more too with the CW3E tools of where soil moisture is less or where it's higher. So this is total moisture, and then this is just looking at soil moisture. And then also this is true, they do monitor this for snow water equivalent. It's really early to do snow water equivalent for this time of year, but I just wanted to make sure that you knew it was available. The one last thing I will show on the CNAP site is this percentiles tracking. And so this is something that was Ann Steineman helped develop with Sam Icabellis several years ago, but it's a way to kind of see, just in terms of precipitation, how the current drought compares to historic droughts. And so it's done by climate division, and so you can see the different climate divisions here in California and Nevada. Right now we're in the state of California, climate division 2, and so this is what it is. And so this is showing the percentile for drought on different time periods. So this is for 1 month, 3 month, 6 month, 9 month, 12 month, 24 month, 36 months. So you can see in terms of how long this drought has lasted relative to past droughts and how it compares on these various different timescales. So for this, for example, you can see, where the current drought is, and on the 2-year timescale, it is in the second, between 0 and 2nd percentile. So this is very severe. The other one, obviously, that really stands out for this region is 1976, 1977. But you also see here on this very short timescale of a month to 3 months, especially because of that really wet atmospheric river in October, that that doesn't happen very often, and so you have this really high percentile just for a month to 3 months. And so you can pick your favorite climate division and just it just provides some sense of how this drought compares to historical droughts. Okay, so with that, I'm going to move on to the CW3E website. The website is cw3e.ucsd.edu. Here's the landing page. A couple things that I will just point out. If you're not familiar with what an atmospheric river is, we have a short video. Sorry, I'm not going to play it. It's only 1.5 minutes, but it talks about what an atmospheric river is, and I think it's worth watching. And then going back to the website, so often there are a couple different places I go, but one of the first one usually is this AR, IWV, IVT forecast. And I see with time I should probably start going a little bit quicker, but I'll let you know that these are the deterministic or the best guess model runs. And you can see we have different models. We have the US model, the European model, and then a higher resolution North American model. These are the different forecast time caps, and you can just kind of click through. And this is showing IVT, which is an incorporation of the water vapor and the winds, so how much water is in the atmosphere and the winds. And when you put these together, this is an indication of the strength of an atmospheric river. The other thing I will point out, there's a lot more on this page. I'm happy to answer questions, but is this landfall tool. And so this landfall tool, so the Pacific Northwest has just been getting hammered, you've probably seen in the news. But this is showing the probability using many, many ensemble numbers that there'll be atmospheric river conditions at this latitude, whatever it is. And then this is showing the duration. And you can change it. So you have the US model, the European model, which is the ECNWF, or then you can do this comparison between the two. And when the two models, especially in these out times, are more similar, it's an indication that it's more probable. You can also change the strength of the IVT, and you cannot change the location. So right now we're looking along the coast. You can look along the foothills, and then there's also an inland transect, and you can see how those black dots move along. Then I will switch real quickly to the AR scale products. There's a video that explains the AR scale, so I won't go through it, but the AR scale is a way to indicate the potential impacts of an AR, and so these really have to, an AR 1 and 2 are usually beneficial, whereas the AR3 could be between hazardous and beneficial, and 4 and 5 are more likely to be hazardous. And so this is in the past historical record, what we've seen. So over the last 7 days, there was an AR1 to 2, and then in the forecast, what we're seeing is an AR between AR anywhere from a 1, 2, or 3, and the AR scale is location dependent. So again, you can choose your favorite model, and you can also change the location of where those dots are. And the last thing that I will show is these plume diagrams. And so what this showing, I mentioned the IVT, so this is the winds and the water vapor together, and where that falls on the AR scale. And so it's they're right on top of each other because they're very similar, but you see an A here. And so this is this last AR that hit, this was 55 north, so way up in British Columbia. You can see this was an AR1. And it's showing it here. And this is what we call a plume diagram. So it's taking the different ensemble members or different model runs, and Red is the 1 standard deviation positive, the blue's the 1 standard deviation negative, the black is the control member, our best model guess, and the green is the mean of all these ensembles. And so if we just go to a location, say in Seattle, you can see coming up that there's 2 AR2s that are forecasted, but there's, in this first one, because these lines are closer together, there's a lot more certainty, whereas in the second one, there's less certainty because the lines are farther apart. So Amanda, I will go ahead and stop there. I think there's a lot more to share on. Maybe I can put a couple of things in the chat for people to see too, but I'll turn it over to you so you can talk about the DEWS tools.
Great. Thanks, Julie. Yeah, and that's a good point that I'll mention for everyone that we record these webinars, a reminder, but we also do a little write-up on them. And so I'll try to include as many links as possible for all the different tools that were shared. And Julie, feel free to pop things into the chat while we're doing that. I will ask so this question came in during John's presentation, but Julie, I think you could answer it because it's about atmospheric rivers and some of the tools you were just showing. The question was, how well do the dynamical models capture the landfall latitude of atmospheric river events?
So it depends on the time. I mean, the lead forecast time. I think about 4 days out, if I'm remembering the statistic correctly, it's about 150 kilometers on average in terms of the atmospheric river. But actually what we see is there's quite a bit of variability event to event. For example, the AR5 that made landfall in October is actually really well forecasted, where other ones are less so. One feature that has a tendency to make it more difficult to forecast are called mesoscale frontal waves, or there's kind of that can cause an AR to shift and north or south or also stall. And so some of these in the development of these can make them harder to forecast and have it be a bit more off.
Great, thanks, Julie. So yeah, I'll bring us to here at the close of the webinar here quickly, and then maybe we might have time for 1 or 2 questions. I've tried to answer if you asked a question. I replied directly to you into the chat, so if you asked a question, some of them I was able to get those replied back to. And if we don't get to your questions here, we'll get to them. I'll follow up in in emails to get you an answer to your question. So the last thing we're going to talk about here before closing the webinar, I just wanted to point out some of the newest features of drought.gov, which is the NIDIS website, and it's the US Drought Portal. If those of you who have been on our webinars before know, we relaunched this back in January. It had a lot more up-to-date information that you can find from the city and county level, interactive maps, new by sector, a lot of go back to the basic research and learn information. And so I'm just going to pop right back to the website real quick. Just to give you guys a refresher, so this is our homepage. Just a lot of the tools that Julie is sharing, John is sharing, and others are all integrated here into the Drought Portal. And so, for example, here under data and maps, you can go to different categories of things, and I'll select, for example, snow drought, where you'll be able to see, maps that are related to this, discussions, and then also basically every tool that we could think of, and we are open to adding more tools related to this category. So for example, snow drought. So there's a lot of snow tools here, including CW3Es, freezing level forecasts, and things like that. And so I just want to remind folks that there's a lot on here like that for data by sector, very similar pages. And then you can also dig in deep into locations by tribal regions, county, watershed, state, local, and then our drought early warning system regions. And so for example, here I've pulled up the state page. I'll pull up the state page for California to give you a sense of the kind of information you can find there, including a lot of the details on current conditions and things, what the US Drought Monitor has shown in the past, what paleoclimate data has shown in the past for this area as well, and then all kinds of resources, including webinars like this, documents, and state level resources. So if you want to find your state climatologist, your COCO-ROS, your USDA information, weather service, regional partners like the Western Regional Climate Center, you can find these all on our state pages as a quick one-stop shop to sort of go find all these different informations. As I said, we've got a lot of different geophysical scales, including counties, And so here, for example, I went to by location, select a county, and then I'm going to go to, for example, Washoe County here in Nevada, to show you also as well, to remind you that you can find a lot of information by county as well. It's a little different than our states. You'll get a lot more statistics, a lot more maps, including drought indicator blends, agricultural information, water supply, public health, and some of the CPC tools are integrated here now, as well as the Backward Demand Drought Index. So a lot more information as well on the county pages to dig deeper specifically into your own location. Move back over here. So that was just a reminder of things we've had on for the past year, but we're continually updating and improving the website. And so one, I just wanted to mention again that we do have new interactive maps on drought.gov. So now you can make customized map and use the download icon to download those, view them for your, again, for your geographic area, state, county, get a really high quality image for sharing, like if you're doing a presentation on it, things like that. We found that's really helpful for folks who are, one of the biggest things they want to be able to grab images for it. And we also have interactive economic sector maps that use GIS technology to take that sector specific information and put it and overlay it with drought and climate information. And then quickly, our newest and greatest tool, which you should probably, if you're on our listserv, be receiving an email about it coming soon, you can now sign up for Drought Outlook email alerts. Previously on our web page, if you go to the bottom of the page or go to this link on the bottom left-hand side, you can look for, you could have gotten notified about drought monitor conditions in your area, and so you would have got an email and alert to what was happening. Well, we've now improved that tool to also include the U.S. Drought Outlook. So similar information that John presented, you can receive an email alert every time the National Weather Service produces their 1 and 3 month drought outlook. And so you can find that either at the link in the lower left, just go to drought.gov and scroll to the bottom and sign up for alerts, or there will be an email coming out if you're on our listservs on Monday, I believe, to be able to sign up for this feature. And so with that, since we are running over time, I don't want to keep people long, but if you do have a question that I wasn't able to answer, I will come back and answer it for you through email and follow up with our experts and things like that. So I'll just go ahead and close out and say thank you all so much for joining us today, and thanks to John and Julie for presenting and sharing tools and resources. As I mentioned, a recording will be available, and I'll also do a little write-up, bolded write-up that goes with that, and I'll include as many of these tools and resources as I can in links so that you guys can find all of these great things, especially as we track drought this coming winter. Our next webinar is scheduled for Monday, January 24th. You can already find that on drought.gov on the events calendar. You'll get an email after this when we send out the recording and everything. And you can also look out for a California Nevada drought status update, likely in December, as well as our first Western snow drought status update, both of those providing information on the current conditions and what's happening. With that, again, I'll just say thank you all again. And if you have any remaining questions, want more information, or want to become more involved with the California Nevada Drought Early Warning System, please don't hesitate to reach out, and we'll be happy to talk to you. So with that, thank you everyone, and I hope you have a great holiday week.